folks, let's take a look at another quadratic inequality. We're going to solve it graphically. Write the solution in interval notation. So I see my quadratic. If I want to graph it, let's get some intercepts. Let's get some vertices or the one vertex, right? And then I'll check it on my handy dandy graphing calculator. Now, things that I notice, or the main thing I notice right away, is that I've got a negative lead coefficient. So when I go to graph it, I'm ultimately going to have an upside down parabola, which is fine. It's just helpful to know that's what my graph is going to look like. So let's go find x-intercepts. I'm going to do this all by hand initially, and then I'm going to just check everything on my graphing calculator. I want to make sure my algebra work matches what my technology is saying. So if you ever want to find an x-intercept, you always let y equal 0. So for this particular problem, that means set your quadratic expression, negative x squared plus 10x minus 16 to 0. And you could factor, complete the square, use the quadratic formula. I personally am going to factor. And when I factor, for me, I don't like to have a lead negative, so I'm going to factor out the negative, which means I'm going to change signs on everything. All right? And then I'm just going to solve this, or I'm going to factor this quadratic equation or expression. It's easier for me in my head to factor something with a positive lead coefficient rather than a negative. So I'm going to leave this negative out here. All right, so two numbers that multiply to 16 but add to 10, I'm going to go, or add to negative 10, are x minus 8 and x minus 2. Right? And then I can use the zero product property. So either x minus 8 was 0 or x minus 2 was 0. So ultimately I get 8 and 2. Or if I think about my intercepts, I'm going to have one at 2, 0 and one at 8, 0. Okay. All right. I also like to find y-intercepts. And I'm going to have a pretty, I want to say I can tell I'm going to have a pretty low y-intercept. It's always that constant. But to find a y-intercept, let x equal 0 and then solve for y. So this is going to be negative 0 squared plus 10 times 0 minus 16. But like I said, I could spot my y-intercept just on the formula. So this is going to be negative 16. So my y-intercept is 0, negative 16. So as I start to think about graphing this, I'm gonna need to have some space on the bottom. I'm gonna have to graph pretty low. All right, I also like to find the vertex. And if you ever want to find the x-coordinate of your vertex, the formula we have is negative b over 2a. So in this particular case, my b value, the number in front of my linear term was 10, so I have negative 10 over 2 times, all right, my a value here was negative 1. So I ultimately have, negative 10 over negative 2. And that's going to be 5. All right, so there's the x-coordinate of my vertex. If you want the y, then plug 5 back in. Let's see what we get. We got negative 5 squared plus 10 times 5 minus 16. All right, so this is going to be negative 25 plus 50 minus 16. So negative 25 plus 50 is positive 25. 25 minus 16 is 9. So my vertex is ultimately 5, 9. All right, now before I go graph this, let me just check this out on my calculator. Let's clear out our previous problem. So I'm going to keep the negative x squared, but I want to change this to positive 10x minus 16. Let me hit zoom 6. And let's just make sure everything is consistent. So I do see an x-intercept at 2, 0. I do see another x-intercept at 8, 0. That looks good. I can't quite see my y-intercept because this goes down to negative 16, but my window only goes down to negative 10, right? That was the y-min. If I wanted to, I could change this to something like negative 20, and then I would see my y-min. I would see my y-intercept, but I don't really feel like I need to. All right, let's see if the vertex, does this look to be 1, 2, 3, 4, 5? And that does look like it's 9. Let me just check by doing second and trace, calling up my calc menu, and doing option 4. I just want to check that this 5, 9 is correct. So let's do option 4 and pull up Blinky. Let's get Blinky into view. So if I think that my vertex is here. Well, not I think, that is my vertex. This blinky right now is left of it, and they're prompting left bound, so I'm gonna hit enter. I'm gonna move to the right. Now I'm on the right, and I'm gonna hit enter, and then I'm gonna hit enter through guess. And 5, 9, yeah, I've confirmed it. Okay, so with that, let me go ahead and graph this parabola, and then let's see if we can't solve our inequality. Okay. All right. And what did I say? I want to leave. Oh, you know what? I want to leave. Oh, sorry, you're hearing I have a meeting soon, and all of my notifications are going. All right. So let me. I'm erasing this just a little bit. I want to leave. I want to have -16. I want to have room for -16. And now that I think about it, I also need room for +9. You know what? I'm just going to scale this in a really small manner because this is a pretty wide spread graph. All right, so let me go ahead and make, and then where are x coordinates? 2 and 8. Okay, so let me go ahead and give enough room for this. Okay, and then we'll go ahead and, oops, sorry, making all sorts of noise. We'll graph this out. So I've got 1, 2, 3, 4, 5, 6, 7, and 8 in the x direction. So I'll make sure I put my x-intercepts at 2 and 8. And then I've got -16, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I've got 5, and let me go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's gonna come out of, okay, 1, 2, 3, 4, 5, 9, like here, somewhere there. That's good enough. Right? And I think we can still see the rightmost part of my parabola here. All right, so I'm gonna graph that. Wait for it, that. Right, so there's my parabola. Now I want where this is strictly greater than 0. So I want, where is my graph above the x-axis? I'm not interested in where it's below or where it's on. So when I look at my graph, it is above the x-axis in this region, okay? And when you write up your intervals, you only write up the x coordinates. And it started at 2, ended at 8. So what I want to say is x can be anything from 2 to 8. Oops, let me write that. It can be anything from 2 to 8. And for this particular problem, I want parentheses because I do not want to include the 2 and I do not want to include the 8. All right. So moving forward from this, we're going to create something called sign patterns because this is the last example where we solve these graphically. In the next set of instructions, it's going to say solve it algebraically. And we're going to create these things called sign patterns. And I mentioned this when we were just looking at the learning outcome from the front page of this section. These, we're going to introduce them here, all right? And they're going to play themselves out just numerous times as your math career kind of develops. So what's going to happen is we're going to take this graph, right? And we can take any graph and we smush it, okay? So you're going to hear me talk about smushing this graph basically essentially down to just an x-axis, all right? And so I'm going to give you a preview, all right? What we're going to do is we're going to, instead of making x and y like that, we're just going to draw an x-axis, okay? And what we typically do is we'll label our x coordinates down here, and for this particular graph, I would put a 2 and an 8. All right, and what would happen is above these, I would say at 2 and 8, and let me erase this word sign patterns because I actually need to label this, okay? What we typically do here is we'll say, hey, we graph the x coordinates below this line, and then we graph the signs, okay, again, because this is a sign pattern, all right? And when I say sign pattern, we're interested in pluses, zeros, and minuses, above the x-axis, on the x-axis, below the x-axis. But we're gonna say that when we have negative x squared plus 10x minus 16, what was happening in terms of the signs is when x was 2, this quadratic expression was 0. When x was 8, this quadratic expression was 0. When we were here, when we were left of 2, yeah, this parabola was below the x-axis, right? It went from below the x-axis to on the x-axis to above, right? My function values were positive, to on to below. All right, and that's what a sign pattern is ultimately going to be. If we squished this down to where we only cared about the numbers of the x-axis, but the signs of the y, right? Positives, negatives, or zeros, that is a sign pattern. And we're going to create a bunch of those with quadratic inequalities. Then we're going to move to rational inequalities. And then when you get to calculus, you'll make sign patterns for your derivative. All right, thanks so much. Bye.